All right, so hopefully this will seem like a little bit of a review. We're looking at factorial notation. We're going to start with a review question. Each of the 6 members of student council must give a speech at an assembly. In how many different orders could they speak? So there's no special conditions here. So we're going to write down what's given. Our available information is that we have 6 members of student council. What's required? We want to know the number of different speaking orders. And so what's going to be our solution? Well, in this case, we've got a total of 6 members. So it's really just a matter of saying that we've got our first member. There's 6 possibilities for our first member, right? Our first member. And then once our first member has been chosen, there's going to be only 5 members left for the second position, and then 4 members left for the third position, 3 members left for the fourth position, 2 members left for the fifth position, and that will leave just 1 person left for the sixth position. We multiply those all out, and we get 720 possible ways of putting the students in order to speak. Our final statement, there are 720 ways, 720 different speaking orders. Now, the reason this lesson is called factorial notation is because this pattern of 6 times 5 times 4 times 3 times 2 times 1 is known as factorial. We can simply say that's the same as 6 exclamation mark is equal to 720. So this exclamation mark refers to 6 times 5 times 4 times 3 times 2. All right, so with our factorial notation, it can be used to represent the multiplication of consecutive whole numbers from a number n down to 1. So if I started at 3, it would be 3 times 2 times 1. An exclamation mark is written after a number to represent a factorial. So n exclamation mark is, we would read that as n factorial. The example here, 5 factorial simply means 5 times 4 times 3 times 2 times 1. That's 120. 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is a larger number, 3,628,800. So n factorial, we can write that in symbols. We would start with the number n. The next number is going to be 1 less than that, so n minus 1. 1 more less than that, so whoops, n minus 2. N minus 3. We continue all the way down until we're left with 2 times 1. So some examples of what that is. In this case, 10 factorial divided by 7 factorial. We're asked to calculate this without using a calculator. So we know that 10 factorial is simply 10 times 9 times 8 times 7 dot dot dot. And 7 factorial is 7 times 6 dot 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 all the way down to times 1, right? So in this case, we can see that the 7 times 6 times 5 times 4 times 3 times 2 times 1, that's the same as the 7 times 6 times 5 times 4 times 3 times 2 times 1. So these are going to simply divide out. And what we're really left with is 10 times 9 times 8. So 10 times 9 is 90, times 8 would be 720. Unfortunately, with a subtraction here, there's not going to be any shortcuts, no easy steps. So that simply becomes 5 times 4 times 3 times 2 times 1, subtract 2 times 1. So that's equal to that, which is really 5 times, that's 120. We've already solved that. Subtract 2, we're left with 118. And then again, the same shortcut applies for C. This is the same as 203 times 202 times 201 factorial divided by 201 factorial. 201 factorials divide out, and I'm left with 203 times 202. I am going to use a calculator for that, and that gives me 4,106. Okay, but the idea here is that we've simplified the problem.